Hello, this is Sebastian Lerich from the CloudScale project. Welcome to this new screencast series of ScaleDL, our new language for specifying and for analyzing cloud computing-based systems. I'm now starting with our webpage of CloudScale because I want to show you where you find the information about ScaleDL. So you can just go to Results and select Language here. And there you find an overview of ScaleDL, this language this screencast series is about. Here you also see there are different sub-languages included in ScaleDL, such as the Usage Evolution sub-language, architectural templates, overview, and some reused languages such as the extended PCM you already know from previous screencasts about the extractor and the analyzer, as well as we now also included the Descartes load intensity model, which is an external project that allows you to specify dynamic workloads, so workloads that can change over time. In this first part of the screencast series, I'm going to show you how we allow to specify Descartes load intensity models and how we can link them to the extended PCM as we specified before using our usage evolution language. In this overview diagram you also see the relation between the three. So there you can specify a Descartes load intensity model in separation. We have already specified an extended PCM instance in earlier screencasts, in particular the usage scenarios. And what we also want to do is now to create a new instance of our usage evolution instance that actually links between these time-dependent workload models to the usage scenarios like we are used to. Okay, so let's switch to Eclipse and see how we can specify a Descartes load intensity model. In my Eclipse you already see a result I previously created. So this graph in the lower left here shows a model representation of a Descartes load intensity model. It shows on the x-axis time and on the y-axis arrival rates. Depending on the usage scenarios, this y-axis could also represent the number of users in a closed workload. For an open workload, of course, arrival rates are quite fitting. We now see that there is a linear trend over time. So at time 0, the arrival rates are also close to 0, but we linearly increase over time the arrival rates. So that's what's specified here in this model. Later on we can also link that to the extended PCM as we created in previous screencast. This example comes currently with our Cloud Store showcase. You can also download from our Git repository. I just checked that out into my workspace and opened this folder where we have usage evolution models and also the Descartes load intensity model inside. What I'm going to do now is I add another Descartes load intensity model to this folder. So I do this by right-clicking on this folder, choosing New, Other, and from this list here I can now choose the folder Descartes load intensity model, and there's only one option for this model. I can go with Next. I have to give the file a name. Let's model a month. And I can go to Next then. And here I can now specify which types of time-dependent functions should be included. So there can be a seasonal part, a trend, and recurrent burst noise. I could also extract a complete model out of a trace, for instance, received from server logs. Yeah. But now I want to specify a new model, and I want to also specify all parts, such that we can see every part next. So going with next allows me to specify the seasonal pattern. The seasonal pattern is a pattern which reoccurs over and over again in periods. So for instance, I could specify a period of 1, maybe modeling 1 day within my months. And everything we see now in this preview would then model this 1 day. Okay, so I could, for instance, think of a day that has a certain number of peaks over the day, maybe let's say 2 peaks. Of course, I just jump down here. We have something called interval containing peaks, which is now set to 12, which does not really fit in the period of 1. So I should set that to something like 0.5. And now we also see in the preview how this function would now look like. So we have now a period of 1. So that's why we here on the x-axis see from 0 to 1. We have 2 peaks, as you see here. And the interval that contains these peaks has a size of 0.5. So that's from this peak to this peak, the width. I can also specify some other things. So I can specify a base arrival rate. So I could, for instance, start with 2.0, so which leaves the starting and the end point going up to an arrival rate of 2. I could specify a base arrival rate between peaks. So currently it's at 0, but if I, let's say, move it to 1, it's a bit increased. I can also specify a first peak arrival rate. So now it goes up to 10. Maybe that was too ambitious for the time being. Maybe we just go up to 3 here, and that's it. The last peak, I can also specify how huge the last peak is. So maybe that goes up to, let's say, 5, and we get a curve like this now. What I can also specify is the general shape behind this function. So currently it's an exponential trend, but I could also choose between linear trends, which would result in such a graph, a logarithmic trend, or what I will do is a sine trend, which would now look like this. So this could, for instance, model 1 day of usage of our cloud store now. So in the morning there may be some peak. During lunchtime everybody is having some food, so the system is left. But after lunch there's plenty of time of ordering books until we finally arrive at home after work. A lot of people order books. So that may be a typical day for our cloud store. So we finish now with a seasonal pattern, which is repeated over and over again in the whole month I want to model. Speaking of the month, we can go now to next and specify the overarching trends, which would be in my case a month. Let's say of let's say of 30 days. What I can now do is I can interpolate this different seasons inside one trend. So let's say we start with an interpolation value of 10 and we will go up in 1 month to, let's say, 30. And now we model that we go from an arrival rate from 10 in this month to an arrival rate of 30, which now specifies that we expect like an increase in arrival rates in the first month when our cloud store starts being online. This may be an exponential trend, but we actually expect a linear one. So alternatives would be logarithmic and sine, but we go with a linear trend. You have also different selection operators. So we now multiplied here for specifying the combination of trends and seasons. We can also choose add or subtraction, but I will go with multiplication. In this graph below, you still see the underlying periods in a series of such periods. And derived from that is the linear trend I additionally now modeled. Using this checkbox, you can optionally also remove this additional information and just have a look at the general arrival rates, how we modeled them so far. Okay, so that would be what's happening over 1 month in our cloud store. Still, it's quite deterministic, and therefore we next add some noise to our graph. So what we can do is, for instance, so in this next part of the wizard, you can also specify recurring bursts. I won't specify these now, but I'm interested in some noise adding to my function, which could be, for instance, let's say maximum noise arrival rate of 20. So I get some noise inside 20 would look like this. This may be a bit too much, looking like this now without the other display. Maybe 10 is nicer. It may still be too heavy, so 6 looks quite good. So I added now some noise to my function for this month. This finishes already the specification of the decar intensity, load intensity model. So I can now just press finish, and as you see here in the arrival rate plot view, it's updated, now showing the model I just specified. If I need to adapt this model somehow or alter it again, I can use this tree editor that is also opened to alter what I specified before. So you find all this information again here in this tree editor. You have, of course, to open the properties view. So you can alter all the things I specified before also here in this tree editor. For details, I would refer to the decar project, which provides a lot more details about how to specify such models. The crucial thing for our tooling is that we can now actually link such a specification to the so far created models. And we can do that by specifying a so-called usage evolution model that comes also as part of ScaleDL, which is actually quite simple. So we can go again to new, other. And if you're here, you can actually enter a usage evolution model. So you find here this usage evolution model. You can go to next. We have now months or monthly usage evolution. Go with next, and here we have to specify a root object, which is just the usage evolution root. Can press finish, and we are currently provided with this tree editor that allows us to specify usage evolutions. So linking this previously specified decar load intensity model to our existing models. So we can give it a name like monthly usage evolution. We can specify a child, which is called usage. We can also have additional childs, but one is enough for the time being. The usage may be called browsing mix, so it's just a name. Because browsing mix is one of the usage scenarios we previously specified in previous screencasts. So there's a browsing mix usage model, and if you just want to see the diagram, I can also open it for you. It's the like the distribution of possible calls to our cloud store. It's specified here. in the previous screencast. What we now want to do is we actually want to link this arrival rate plot to the population number here, and make this population number not fixed to 10, but make it time depending. So starting with 0, we have something around 10, but it increases over time and with certain peaks. Okay, so to link it now, so this model to this number here, we have this model. We can here specify what is our load evolution model, so our Descartes load intensity model, and we can also specify the scenario of the extended PCM for that. So now it's quite easy to add that. We actually just have to move the different files into this editor, for instance like this. We can then just select it. So maybe I select the sequence for a month. I also have to link to the browsing mix usage model. I can also drag and drop it, simply like this. And then I can just choose the browsing mix here. I can then save the model, and I'm done specifying it. The analyzer now considers this load evolution, and you just have to link this model to be used by the analyzer. That is shown in a different screencast where we show the capabilities of the analyzer for such models. The focus of this screencast was just to show you how to model like these workload patterns. In the next screencast, we will again go back to this ScaleDL language here. We will further provide some additional information to our model regarding service level objectives. We will make later on also use of architectural templates, and I will show you how to use the analyzer using such languages. So stay tuned for the next episode. I hope you enjoyed it. See you next time.